is from Nova's Group. So we are privileged to be here to come and explain or put you through some basis of electronics design using some application and how to fabricate PCB. And I want to understand maybe the majority of the people here are electronics people. Am I right? So that sometimes terminologies being used will not be strange. The only thing that maybe will be different is maybe the application that maybe we'll be using to guide you through the designing process. That does want to be different. And also after the design process, we'll be training you on how to fabricate a PCB. So once again, my name is Melo Bashir. I'm here with my colleague, Engineer Gideon Ojo, who will be the one that will be taking you through the design class for the meantime. Thank you.
We are going to start with PCB design. We have two sessions for this class, which is PCB design and PCB fabrication. So the fabrication aspect is more of a practical, while that of the PCB design is making use of a CAD software. So we are going to give you the software in which you are going to use. And actually, the software we are to use during this training will be Deep Trace. I don't know if you've heard of Deep Trace before. Deep Trace. Yes. DIPPRACE. We have other softwares. So at least we have other softwares. I think you people are familiar with some other softwares in the PCB design. Or let's say PCB in PCB schematic design. Let me put that. Yeah, we have Frontiers, which you use for schematic design and simulation. We have OCAD, we have PU, we have Otion, and some other software like that. But majorly, the one I've been using for decades now is Deep Trace and Eagle. But I find Deep Trace more interactive than other CAD software. So, but before we go into that, so before we start with that, I would like us to first discuss about PCB. The word PCB means what? Printed circuit board. A printed circuit board is a platform in which electrical signals will be what? Transmitted through what? Electronic device. Every time you turn on any computer system or electronics device, you are interacting with the what? Printed circuit board, which are inside the what? Enclosure of all such devices. If electricity in the lifeblood of electronics, printed circuit board are the what? Vital internal organs. Without printed circuit board, modern day technology would have never become what? Possible. As it is, looking at it today, any electronic device you have with you make use of what? PCB. So there's no how you want to come up with a design in which you make sure that there won't be a PCB inside the what? Device. So unlike before, this is an example of a PCB which you are seeing. On the other side, you are seeing a copper clad board. Before you have a PCB, you start from what? Having a copper clad board. A copper clad board is made of what? A glass fiber laminated with what? Copper. Laminated with what? Copper. It could be a single-sided, it could be what? Double-sided, it could be what? 4 layers, and it could be what? 8 layers. But the sample we are seeing here is the what? Double-sided what? Copper clad board. So the process at which this during fabrication, the copper clad board pass through many processes to become a what? A PCB. So the old ways of or let me say how we do some of our projects here while you are in school or already giving projects, the first stage, most times, you start from what? You start from having the schematic diagram of your design. When you have the schematic diagram of your design, the next thing is making use of breadboard sometimes. Then from breadboard, you later transfer it to what? A vero board. So most times this is how we do our design. Traditionally, PCB development is not well standardized in our institutions of learning as a result of what? Inadequate knowledge of what? PCB design and fabrication. The conventional way of development is the use of what? Vero board for most what? Projects. And while you are doing all these projects, I don't know if we've had experience in using vero board, whereby you will design the same circuit repeatedly, but you have different what? Outputs.
Sorry, what means the and want to have just a 5 minutes speech. Hello, sir. Can you hear me, sir?
Yeah, I can hear you. Yes, I can hear you loud and clear.
Alright, so we're on now.
Okay, so can I go ahead and speak? Or good morning, ladies and gentlemen. My name is Fabrication, and I'm the CEO of One Innovation Hub. So I welcome you all to One Innovation Hub and Kalabalo Technology Center. We're really excited about this journey for the PCB and the trainers. As we all know, PCB, the printed circuit board, is something that we need to develop very well in Nigeria. We're excited about the partnership with the tertiary institution, and I welcome all the people, the great people from all the way from Lagos, from the University of Ilorin, all the way from Ilorin, Summit University, Federal University of Technology, all the way from Bina. We really appreciate Federal Polytechnic of our neighbors over there, and all the other people that are on their way to join. We are enjoying this facility because of the chairman of MoMA's engineering, Engineer Kalabalo, who provided the facility, as well as given the machines and the technical people that are there with us. So thank you very much, Engineer Bill Bakir, for leading to Engineer Gideon and all the other people that are going to be working with us for the next 5 to 6 days. We are looking at the partnership between the tertiary institutions and One Innovation of Kalabalo Technology Center, so that we can embed these into the curriculum of the universities, into the polytechnic, and all the other institutions that we have. So we can bring our students back for training, we can bring our products and solutions back for development and commercialization. We pride ourselves to be the biggest in West Africa so far, and we're moving very quickly in partnership with other global organizations to develop the center. So please let's sit back, relax, enjoy ourselves, and taking all the information we can. And we look forward to you coming back. Bring your students, bring your product, and for us to work together in the center so that we can develop Nigeria on one hand and even develop ourselves individually for the economic growth of our families and our nation. So I welcome you all and thank you so much to all my good people here. Kola Lawal is there for you, Ferromi, and all the great guys there. Thank you so much for listening, and hopefully we'll be together throughout this week that you are here. Enjoy the peaceful atmosphere of Copa and eat a lot of sweet potato there. That's what we're known for. Thank you so much. Have a lovely time.
So thank you very much, ma'am. So we continue the
Alright.
session now. So we are starting the design. So Mr. Engineer Abdul already on the classroom and interrupted us in session now.
Please continue. I'll just observe for a few minutes, then I'll go. Thank you so much.
All right, sir. Okay.
Okay, all right. So, like we were discussing before, we were discussing about wherever you have different, um, you have a particular project in which you make use of variable and you repeated the same schematic design on different variables. At the end of the day, you have different what? Outputs. What are the reasons? What causes those things? These are due to maybe signal breaks, noises, crosstalk, flying cables, resistance, inductive resistance, EMC, and so on. And what are the causes of all these things? They may be caused due to what? Jumper wires that are being used. And you know when you have those connections like that, the mechanical strength of the soldering at different points on the board. You understand me now? Even the length of the cable you are using, the length of the jumper, because the longer the cable, the higher the what? Resistance. And all these things will affect what? Your signal. When you are designing a PCB, there are different pin outs from any MCU or component you are making use of. The source, the signal, and what? Communication. Communication on IC could be UART, it could be I2C, it could be what? SPI, and so on. And there are things you know to what? Consider while you are what? Doing your design. But you know, in a case whether you are making use of board or breadboard, you can't put all those things into what? Consideration. Example, you have different jumper cable. One could be made of copper, while one is made of what? Aluminium. You won't know what you have in it. So those are the things that affect what? All those circuits on what? Board. That's why you have what? Different what? Outputs when you have the same circuit being designed on what? On board. So, but with the help of PCB, you can eradicate all this. You can eradicate signal break, noise, crosstalk, and what? Flying cables. It helps to give a what? A moderate and what? A perfect what? Design. So, and this is not good for innovation, incubation, and development. So, let's leave that and let me move to the next slide. Look at this now. Okay, it's coming up. Now, for example, look at these two different board design. Look at how rough it is using a very board, and look at how neat it is. Using PCB, you have a what? A reliable circuit, a durable circuit. So even though you are repeating the same this thing, design, you still have the same what? Output. So apart from the normal PCB, the solid one, we also have a what? Flexible PCB. And most times now, I think they are making use more of what? Flexible PCB now. That's why you have mobile phones that you can fold. That's why you have TV that can slide in and out with the help of what? Flexible PCB. A flexible PCB too is made of what? A film. The film is being what? Laminated with what? Copper pulp. It's being laminated with what? Copper. It's just like when you have a film and the film is what? Laminated both sides. So we have flexible PCB that are what? Single-sided, and we have the ones that are what? Also double-sided. But the process of achieving or making a flexible PCB is more complex than the normal what? PCB we all know. So now, what are the benefits of PCB design and fabrication? Like before, I think I've explained miniaturization. It reduces the what? Space or size. It makes it more compact. So the space you have to use will be what? Reduced. And there will be what? Durability. Your design will be what? Durable. And there will be what? Safety. There will be what? Safety. So, and it will be what? More efficient, more what? Economical and repairable. So even though there is a fault on your circuit or due to one thing or the other, you can easily what? Trace it. Okay, well, this track is coming from pin so of this IC going to a particular resistor. You can easily what? Identify it. So that's it. Then, advantage of learning PCB design and fabrication. It is the foundation of what? Electronics. It is the bedrock of what? Devices. It drives innovation in all fields, and the knowledge is paramount to what? Quality PCB design. Prototype your idea on an actual PCB for what? Neatly professional design and what? Presentation. Then opportunity to become a what? A freelancer or self-employed. Even though you have other work you are doing, at your free time, you can get contract of what? Designing PCB for what? Anybody for a particular project. All you need to request for is the what? Schematic. Once you get the schematic, you are good to go. So PCB design and fabrication skill is what? Is global. Hence, the students have the opportunity to work for what? High-tech electronics industry anywhere in the world. So what we just did now is just for us to have an introduction about what? PCB design, not fabrication. So that's it. But when we talk about PCB design, can anybody just come and design a PCB? Like there's some knowledge you need to have before you can say you want to design a PCB. First thing, the person must have a good knowledge and background in what? Electronics, which is very what? Important. And I think most of us, we have the knowledge already. But I would just like us to what? Glance through what? Introduction to what? Electronics. It won't take much of our time. But where I really need to hit the point, I will what? Talk me about that. So let us just move to the next slide. A brief discussion about introduction to what? Electronics. I won't take much of our time on it. As we all know, that every electronics component are made of what? Semiconductors. Every electronics component are made of what? Semiconductors. So, and the origin of that is from what? We have proton, neutrons, and what? And electrons. So that's it. And making from that, we have making of what? Molecules. Then we have the what? The crystal what? Structure, especially when it comes to what? Silicon. And silicon is very important, it's concerned, whereby they make use to make IC, which is chips, integrated circuits. So, conductor and insulation of electrons, conducting source with what? Excess electrons, conductive band related of what? Electrons too. You want to understand the aspect of what? Conductors and what? Insulators. So, you understand the difference between the two and type of what? Conductors and what? And insulators. So you also need this knowledge, which is very paramount. Voltage, current, and what? And resistance. The analogy when you have high pressure and what? And low pressure. So the conventional current, how it flows. Current has what? Direction, unlike voltage. Voltage is just across. When it comes to current, it flows and it has what? Direction. And voltage in a circuit, when you break and unbreak it, when you have voltage that is not connected to a source, we call it what? PD. And when it's connected, it becomes a force, which is what? EMF. So, and when it comes to circuit configuration, series circuit and what? And parallel circuit. You need to have a good knowledge about that, especially when it comes to resistors and what? And capacitor. It helps a lot. So for me now, if I see any PCB, even though it is not designed by me, merely looking at the component arrangement, I will tell you what they are trying to what? Achieve. I will tell you what they are trying to what? Achieve. So that's it. I know if I see a resistor in series, I know that okay, there will be what? Voltage drop across each resistor. And the voltage drop across each resistor will be proportional to the what? Resistance of the what? Resistor. That's it. And you know what happens when you have a voltage, the same current flows through it. If it is in series, or if it is in parallel, the same voltage across all resistors, but different current flowing through each resistor. And the current flowing through each resistor depends on the what? Resistance value of the what? Resistors. So Kirchhoff's law of voltage and that of what? Of current is very important too when it comes to what? Electronics. These are the basic things you need to what? Understand. You need to have the what? Idea. Series circuit, you must understand series circuit. And some little calculation you need to know. When it comes to, you have voltage being supplied across what? A series circuit, what will happen? And when you have it in parallel circuit too, I don't know if we waste much of our time on this. I believe you all have knowledge about this before. Huh? Yes or no? Yes. We are here for PCB design, not electronics. So, if you are here, that means you should have passed this stage before you start doing PCB design. Yeah. I can still emphasize more on this. These are what? Electronic circuit and what? Schematic symbols. The schematic symbol is used to represent a what? A particular component. Every component you see has a what? A symbol in which it is being used to represent a what? Component. So you can see that we have different symbols there representing it. And this will help you in what? Making your schematic design. Because schematic, what's a schematic design? Is where you have all the component graphical symbol being what? Connected to each other. And you are representing each component with what? With a graphical symbol. And it's very important you can identify them. When you are giving a schematic, you should be able to say, oh, this is a resistor, this is a styrostor, this is a diode, or this is an LED. All those components you must have good knowledge about what? Graphical symbol. So, and you can see that those are some components and they are what? Graphical symbol. Not only that too, even for there are some graphical symbols that are not meant that are not for components like source, voltage, ground, analog ground, digital ground. They all have their own symbol. DC source, AC source, all those have their own what? Symbols. You must have good knowledge about all those ones too. And you must understand which component are what? Active component and what? Which are active component and what? Passive component. So you must understand all this. For example, now the active component are those components which can control, manipulate, amplify, or what? Attenuate. They can add power to the circuit depending on the what? Source. So that's it. And components like this, they said they can amplify. You understand me now? So you also need to know which components are what? Active, which components are what? Passive. Because sometimes you may have a particular trace on your PCB design that generates or emits a hand wave. So you must know that, oh, this type of component, if it is passive, it can distort the signal. It can distort what? The track or signal. So you should have all those knowledge. When you start the PCB design, you get there. So we have the passive component too. These components cannot add any power to the what? Circuit. There are a list of them, you can see them there, which are the capacitor, inductor, resistor. So example of active and example of what? Passive components. Transistor, amplifier, diode, two, it has its own effect depending on how it reaches of it. LED 2 emits, photodiode 2 receive, IC, depending on type of IC, op amp, LCD display, and battery. While the passive resistor, LDR, thermistor, capacitor, inductor, switch, transformer, and so on. And color code, I don't know if you still remember. To me, to be honest with you, I don't remember again. I don't need it. I'm serious. It's done at those days you need to have this thing in your brain. You don't need it again. Most times. But if you've been working on board, like me now, if I see any resistor, I can tell you the value. Because I'm used to it. If you tell me what's the color, I do not know it. But if I see it, once I just see it, I'll tell you this 5K, this 5.1K, this 10K, this 1K. Because I'm used to seeing it every day. I'm used to it. So that's it. So resistor calculation of this Ohm's law. Ohm's law, capacitance, I have knowledge about this, inductor, height, everything. Semiconductors too, E type, N type. computer, you should have knowledge about this, especially transistors too. Transistor is one of the most toughest components that took much of my time in electronics. You can just think we just have transistor. When it comes to BJT, we are good to go. But when it comes to FET, we have different type of different type. Apart from P channel or E channel, we have the depletion type and different depending on how you want to make use of it. When it comes to what? FET. So resistor social circuit, logic gates, should have knowledge about all these ones. So then another thing is that you must know how to make use of what? A multimeter. It is very important. You must know how to make use of what? Multimeter. On how to use it to check voltage, current, frequency, or test your what? Transistor, or continuity test. Especially when you have your PCB design and you want to check something is wrong. You must know how to what? To check all those things. So measuring voltage, that's that. Measuring current. You know, when you are measuring current, it will be associated with what? Circuit. When it comes to electronics, when it is AC, it is about clamp. So I think that's all for the introduction. I think we all have the software. No. Okay, you are still going on. Is there any question you want to ask about introduction to electronics? And please, who has designed any circuit before? Electronic circuit? A project. Which project is that? Jamming device or what? FM frequency. Which MC do you use? Do you use any microcontroller for that? Okay. Apart from that, which other one again? I hate anything. I don't like the competition. The reason why I don't like it is because you can't see what you are doing. You just assume. You just assume that it's working. Or else it will work unless you bring it up oscilloscope to check the what frequency and some other things like that. So that's it. Which other project again? Sir? What I did very well. Okay, inverter is very well. Okay. How many? Which other project again? Yeah? Blind walking stick. What was that? Okay. Okay. A blind man. Okay. At what range before you get to the obstacle? 100 centimeter. So it will just vibrate or what? Pulse. Okay. Just to alert that you're about to. Circuit. The first circuit we are going to design will be a 5 volt power supply. We have different type of power supply. Major key. The two types of power supply we have is we have linear power supply and we have switch mode power supply. So I want us to design a simple what 5 volt power supply, which will be a linear power supply. You understand what I mean by linear power supply? A 5 volt linear power supply. What's the problem? That's what I believe. Most times, when you are working with softwares like CAD software for PCB design, you make use of the mouse. You make use of the mouse. So, the transformer you created, you are still going to create a pattern for it. You are going to do what? Create a pattern for it. Because what you created now is just a what? Graphical what? Symbol representing the what? Transformer. Good afternoon. For those of you that are just joining us, because we started with an introduction to PCB and the advantage of PCB to the existing Vero board and breadboard that are being used in school projects and institutions or some other projects outside school. The advantage and why PCB is important, why making use of PCB is important than making use of Vero board. And we've also discussed introduction to electronics. Because for you to come up with a PCB design, you must have a good vast knowledge about electronics. That's it. So I don't know, maybe you have your experience in electronics, man. Okay, man. Okay, man. So that. Okay, so that's it. So there's a kind of software we're trying to use, which is a deep trace. We have other software that are being used. We have Proteus, we have OCAD, we have Eagle, we have Otium. But basically, what I use is Eagle and deep trace. So, but for me, I found deep trace more user friendly than some others that are more uh, complicated to easily use. Even though you use any software, the end result is for you to get your GABA file and your drill file for PCB fabrication. You understand what I mean? Even though you use any other software, the end result of what you need to fabricate the PCB is what? GABA file and your drill file. Even though you use Altium, at the end of the day, what you need is just what? GABA file. You understand what I mean? No matter what, if you use this trace, use another, it's still what? The same thing. But this trace is more friendly to use. And we've been using it for so many projects so far. We've used it for the military, DICOM, so all the projects, the steam trace we've been using so far. And electricity meter. I don't know if you've heard of a MUMAS meter. So it's still the same software we've been using. So that's it. So then basically we discussed about component identification, component graphical symbol, and now we've started using the software. The first stage is to create what? Know how to use the software to create what? Graphical symbol. It's not a big deal. We have all the graphical symbols in the library just for us to know, okay, in case you want to come up with your own, or you just feel like, let me create a graphical symbol for a particular what, component. You can easily what? Do that. So that's why I'm coming to this room. Then another thing, all these panels, control panels. Assuming you want to do the connection diagram of a control panel, you can't easily find graphical symbol of most of all the what components in the control panel. So with the help of this, you can easily what create a graphical symbol to represent each what component in the what in the panel, like the breakers, the contactors, all the fuses. You can easily what create it the way you want it to look, the way you want it to what to look. So that's it. So we started. I think they will install the software for you on your system now. So they will do that. Yes, sir. Okay, they will go on.
Please, I want to ask because I'm done with the transformer.
Okay.
That pin labeling. I'm still stuck. I don't know.
Pin labeling.
The number.
Have you done it?
Go to view. View.
Okay. And the CP number. Okay.
You see pin number. Then
Oh, it will show.
Okay.
Thank you.
I think we should be through by now.
Sorry, please. All the test. Red test for now.
See,
Just T.
yes, that's the regular for transformation. It's T. Very slow. It's too far to this place. Mm. No, con instant straight.
Mr. Ismail, ẹ máa bá restart ṣe bí èèyàn kò sí mẹ́rin. Ó lè wà ń bẹ̀rẹ̀, ó lè wà lórí podium. Yes, sir. Please, please look at help me. My number is here.
It's still not showing what?
It's done. I've done the number.
Okay.
But it's I don't. I want to increase the font size of the number. I want to increase the font size compared with the other things. The number is too small. I don't know how. On the properties, there's font size there.
Size is there. Font size. It's very friendly to use.
Looking to ask question. Thank you.
Please, are we done with our transformer? So now, please let's look up on. Here's our transformer, right? In numbering, you can see that this is pin 1 and 2 at this side. So this is the what? Primary side. This is what? 3 and 4. This is what? Secondary side. So that the number of turns now can let us know that okay, this one is a what? Step down transformer. All the parameters you fill here, all the parameters filled up at this point. You can see another one here. It's called what? Pattern. If you click on pattern, there's no what? There's no pattern. So now we need to go and create the what? Pattern. There are existing pattern. We have so many existing patterns in this what? Library here. You can see we have a library here full of what? Patterns. You can see. You can see. We have different what? Pattern. So, but for us, let us go and create our own what? Pattern. Then we attach it to what? To it. We've been able to create the what? Graphical symbol what? Successfully. So as for now, there's no pattern on it. So now let's go here. Now, this is where we created the what? Components. At this point, this is where we created the component. So if you are creating pattern, you have to come to here. Pattern what? Editor. So you click on pattern editor. the last pattern I prepared for someone. Yes. Let's continue. So pattern editor is see the same what process, same interface. You can see it. It's the same what process. It's the same interface. So are we on pattern editing? Pattern editor. You come to deep trace itself. This you click it. You see pattern editor. Let me go back again. Come to us. You click on deep trace. Pattern what? Editor. Is what? So come to create new. Pattern editor. Just put transformer there. Put any name you like. Transformer. Reference. You can put it on user patterns. Okay. Please, the library where you are locating it is very important because that's the way that's how we be able to find it. See, let me repeat myself again. New. Just library name is what? Just say trans or transformer. Spelling it there. I'm putting what? Trans 2. This place is very important. Library group. So if you are searching for it, you'll be able to know, okay, when I created it, I see it under maybe patterns or user pattern, component, or what? User pattern. So it's better you save it under what? User pattern. Save it under what? User pattern. So, okay, that's all. Then the name, trans, revdes, T. Revdes for transformer is what? T. Value, 12 transformer. Manufacturer, 1 up. So, you can still remember about this data sheet. You just put the link. Once they click on the link, it will redirect them to what? To the page where you get it. But apart from that, when you are doing PCB design, we have the schematic. After schematic is what? PCB. After PCB, you still have what? 3D model. 3D model, whereby it will show the real image of the component. So, for example, now look at me. I have this schematic here. This PCB design. I have this PCB design here. This PCB design is for one of our meters. You can see it. This is the what? PCB. But we can as well display the what? The 3D what? Model. You can see the 3D model. The 3D model is displaying the PCB alone. It's not displaying the component on it. It's because we did not what? Attach the 3D model to it of the component. If you attach the 3D model of the component to it, it will display the component. So, for example, now too, the 3D model, you don't need to even create it. You can get it online. You can get it online. Let's show you something. Look at this component now. This is a, I don't know how this thing is going like this. This is a what? A transformer. Look at the picture of the transformer. You can see what they put. RS Pro. The RS Pro is their own name that they give to it. 12 volt AC what? 2 output, 2 O PCB what? Transformer. And the power rating is what? 12 VA. So as it is now, you can see they will give you so many details about it. You can see manufacturer is what? RS Pro. Apart from that, you see some other information. Technical what? Data sheet. RS Pro what? Data sheet. Then what did they write here? Log in to download what? Card model. You understand me now? If you now download the card model, if you download the card model and you integrate it onto the software, anytime you want to view that PCB where you use the transformer, it will show the real what image of the what transformer. We still get there. So let me cancel this. So now we want to create the pattern. So this interface. So let us make it. So how many pin connections on our transformer? 4 pin connection, right? So we can just come up like this. This one is showing what? It won't match. You can see what they are writing here. Place pad. Place pad line. Place what? Pad circle. Place what? Mount hole. Which component we use pad and which component we use for mounting hole?
Which company use what?
Yes.
Use what? PCB use mountain board.
Which components, which type of component we use pad and which type of component we use mounting hole? SMD component use what? Pad.
Use pad.
Why true hole component we use what?
Page.
Mounting hole. So look at how the pad will look like. If you are selecting pad, okay. If you are selecting this one is okay, mounting hole is different from pad. This one is mounting hole. This one is for true hole. You get me? This one is for what? True hole. This mounting hole is for like maybe the PCB needs to sit inside the plastic and there's a that's it. But this one here we select now. It has been set. You can change it to what? You can see. Do you understand? True or what? Surface. Let me change it to surface now. You understand? Let me change it to true. True. So you can select how you want it to be. Is it ellipse, up round, rectangle, polygon? Let me just choose polygon. Okay. can see the shape. Can you see the shape? You can copy. So once you want to place, since you've changed the settings, if you come here and place, this is what it will be giving you. You understand? That's what it will be what? Giving you continuously. So our this thing is how many this thing? Uh, four mountain low, right? So let's delete this. Delete 4, right? No, 4. You can adjust it. So since it is 4, just pick 4. Then let the distance between them be 15, 30. So let this one be. Distance between this and this should be what? 15. But sometimes me I just to use my I just do like this sometimes. So depends on how you want to make it work. So how do I say it? Let me my graph process start using this one. How this one.
Excuse me, sir.
Yeah.
I'm thinking of wanting it's not responding on my laptop.
Mounting.
Nothing more. I click on it here, it's not responding.
You mean you click on this? Which one? This?
Yes.
If you are clicking on this, then you place it. You place.
Okay.
Okay. Screw, yeah. So I'm through with my graphical, I'm through with my pattern for the transformer. The dimension, the spacing between each hole will be given to you by the what? You get the information from the component what? Data sheet. But if you don't have the data sheet, make use of what? Vernier caliper. Do you understand? Assuming is an existing transformer that you have with you, and you don't what? Have the data sheet. You make use of what? Vernier caliper. So what are the information you need from to get? You need to know the thickness of the what? Of the pin, how thick it is. Use your vernier caliper to measure it. So that you can use to get the what? The inner diameter of this what? Of the hole. Let me show you an example of how the transformer data sheet looks like. It's not hard now. But most of all this thing we are going through, you have all this information in this thing. By the time you want to do anyone, you see it. Everything that is there already. I'm just putting it through in case. Because for now, if you have an existing component in which you don't have the data sheets, you have to create those patterns. Because if you don't create those patterns, there's no how the component will fit into the what? PCB board. And for every pattern, there's a name for the pattern. So for example now, look at this. All this information, like the diameter, inner, we call it what? Inner diameter. And we have what? Outer diameter. Inner diameter is this O. Outer diameter is what? The outside. So this inner diameter, every information about it is always inside the what? Data sheet. The space between this from here to here, you get it in the data sheet. Even this shape I drew, this rectangle, you get all those information. So this rectangular shape I'm drawing is telling you the area, the space the component will occupy. So when you are doing your PCB component arrangement, you must know that no component must
system. Just let me take this.
See, this is how it looks like. You see what they call it? Can you see it? This is an example of how it looks like. They will give you all what? All the details. So from here, you get what? The dimension. Then there's one thing you should also realize. The unit used most times is what? Is a what? Mm. Is a what? Mm. So this, I just come up with this by myself. So the real distance between each pin and the space it will cover will be given by the what? You see all those information in the what? Data sheet. But if you don't have the data sheet, make use of what? Vernier caliper. Vernier caliper. Data sheets. You are not the component manufacturer. Only the component manufacturer are experts. A data sheet is very. They will give you all information. I think I showed you one example of data sheet for one component. Your laptop. Hello, your laptop is covering me. So this is an example of another component data sheet. Look at this chip. Look at this chip. STM32. You see the dimensions too. Most times it's always like at the last page. All components you see them at the last page. So for this IC now, for this IC, what's the name of the package? FQ FP64. That 64 means the number of pin. That package name is a standard name. It's a standard name for that of the package. So if I'm Teridian now, if my company is Teridian and I manufacture a chip and I name it FQ FP64, this same dimension you are seeing here is what will be in my own data sheet too. If you too manufacture a chip and you package it with what? LQ FP64, it must be what? The same thing. It's a standard. But the only thing that may be different is the word pin. The pin will be the same, it will be the same shape. The pin out to be, but maybe okay, this pin is doing GPIO, this pin is for voltage, this pin is for ground, that one is left to me. But the package, as long as I've adopted LQ FP64 for that my component, it must what be in this dimension. It is me that will now state that okay, pin 64, this is what it's doing. Pin 63, this is what it's doing. You understand me now? So now look at this one now. The package is what? LQFP64. That means it is what? 64 pin. If it is LQFP100, it will be what? 100 pin. So you can see all the dimension here on how to create these are the parts. And the unit is in what? Mm. So for what is it? For a good software, like the one we are using now, I don't need to create this. If I just type XQFP64, it will bring it out. I told you that we have all the lines. But what if you have a component in which you don't even have the data sheet, an existing component? If you buy components locally here, you don't have data sheets. But if you can know the package name, the software will bring it out for you. It will bring it out. Let me just give you an example. No, it will bring it out. It's always there.
The version you are using is like it's higher than the version.
No, it will come. It's there too. I've told you your limitation. More than 100 components. That's all. Okay, look at this one that I created here. I don't remember when I created this graphical symbol. Let me say I want to attach pattern to it. What did I call that before? Okay. P54. LQFP54. Apply filter. Can you see? LQFP what? 64. But it won't match up with this one. This one is having what? 40 pins. So it will have issue. So let me just select one. You understand now? So this is a standard. Nobody can change it. The only thing the manufacturer can do is to tell you their pin function may be different. I can say my own pin number 3 is voltage, 5 is ground. But that component must sit properly on this what? Pattern. So all what you are just doing is just for you to know how you can also do it yourself. So there's no component now. If you have any component, if you have the data sheet, and inside the data sheet they will tell you the package type. Once you just type it here, it will what? Search for it and what? Bring it out. But before you do that, make sure your pin 1, you assign name to it. Pin 2, because if you put this one as 1, if you name this pin as 1, once the software bring out the pin and this one is 1, it will go and pick 1 and it will what? Put it at this pin here. You understand me now? So your pin number arrangement is important when you are creating it. Because it will follow what? The pin number you use here to match it with what? With this pattern. If you make this one pin 1, this is pin 1 here. How do you identify the pin number here? The dots of the chip. So this is pin 1 here, 264. But this one cannot give us the real number because the number of pin here is different from the. So if I want to do it, I should make this pin what? 64. If I make this pin 64, it will now what? Do the proper connection. So there's no. All you need to just come to filter. If you come to filter, just click on all what? Libraries. type this thing there and you want to bring it out. You can say how many results? 60. So there's no difference in them. The only difference sometimes is just the thickness of the this thing. So 60. I want to know which one to pick. This one is 80. So it's different. So we have different. It won't even work. You don't want to use it. So let's say, what is this? Is it mapped? Is 49 mapped? It's not mapped. So look at 40. Stop at 40. See 40. After 40, 41, there's no 41. So it's not connected. 42, there's no 42. So you understand? Yeah, so that's it. But at the end of the day, the nature of this component it will give error that your component graphical symbol does not match. It won't give you the error here, but once you just place it on your PC design, that's when it will start giving error. But there are some, this software has something we call DRC, design rule check. That's design rule check to check any errors.
So does it also not mean that those pins are not going to be?
It will give you error at the end of the day when you are doing your this thing. Once you place it on the PCB, it will tell you that you should check so components.
So it must be 64.
It must be 64.
So it can match.
So it can match. So that's it. So after, have you created your pattern for your transformer? Just create something. Just create a box. Put 4 mounting holes. Name one, pin 1, pin 2, pin 3, and pin 4. It's somehow boring, Abi.
You name the hole.
What I'm telling you to do is just press it. This pattern editor. Control A. Let me just delete everything. Give it your this thing. Have you named it here? After you name it here, this workspace here is not free for me. So that's why I'm doing like this. I'm minimizing. Draw a small box of this size, not more than 2020 sharp. Then place what? Place what? For what? Since we don't have an existing one we are working with, you understand me now? We don't have an existing one. Just make it like this. It's after we're able to go. Release them. Put one here. Those two lines appearing. Those 2 lines appearing means that they are aligned. If it's out, you understand? It's telling you that okay, they are aligned. You don't need to confirm using any stuff. See, they are aligned. They're on the same line. See, they're on the same line. So let us adjust this one to or they are on the same. You can see they are on the same. It will automatically prompt once you click on the component. You can see they are aligned. So then, apart from that, this is your dimension. You have the what? Horizontal, vertical, free, and other ones here. So if you want to take measurements horizontal to check, once you click on the component, it will prompt if it's at the edge, and it will also prompt if it's at the what? Center. So sometimes your dimension could be mid to center to center or from side to right to head. So now, if you want to check dimension here, you can use this to confirm. So this will work for what? Horizontal. If If you are taking vertical dimension, this will work for vertical. From here to what? Here. You can see dimension. You can get the dimension of all anything. Look at this space.
What one are we now working with? 15 mm.
Just create something. Don't let it be.
The polygon, where do you put it? Because my own is filling the polygon.
And that means your whole that's surface mount.
Okay.
Surface mount components don't have pins. They don't have legs in which you are going to place it inside the components. So for now, I've showed you how you can do that. You come here, pad what? Property. Check it to what? True O or what? Or surface. Your own is showing surface like this.
Okay.
If you press OK, you see that you do what? This is true O. This is what? Surface component. But if it is true O, you come like this. Pad. You select what? True O. So you can select the shape, the diameter. You get me now? So that's it. Okay, different shape. So this one should be pin. What is this? Pin. Let's make it pin one. Two. One, two, three, four. This is very important. Pattern. When you are creating your pattern, the pad number or the pin number is very what? Important. You can scatter the the pin number or the pad number on your graphical symbol. Even though if you scatter it, when you are trying to merge it with the pattern, you will correct it. I hope, do you understand what I'm saying? You can, in your graphical symbol, let me explain to you. For example, now, this is your transformer. You name this one 2, 1. You name this one 4, 3. Am I right? But the real pattern of your transformer you are buying, you already know that this was 1. You know this 1. This is what? P. Abi? Primary side. Abi? And you know that this also was P. I know this one. Let's start that. It's not IT sharp. Most times it happens with IC. Let me use IC. Look at this chip. Look at it. For this chip now, let's say this what? VCC. You understand now? This is ground. This one is what? CX. This one is what? RS. And let's say this one is what? Ground again. And this one I just what? GPIO. 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 You understand the meaning of GPIO? General purpose input and output pin. So that's it. So now, as it is now, if this one is 1, this one is 2, this one is 4, 3, 7, 6, 1, 2, 3, 4, 5, 8. It's scattered, right? It's scattered at the schematic point. But in the pattern, in the real pattern, let's say this is the pattern. Let's say this is
This upper side.
huh?
This upper side of the board.
Okay. So this is the graphical symbol. It's scattered, right? But for the components real pattern, you will have to make sure that pin 1 is what? 1. Pin 2 is what? 2. So if you now have the pattern, after creating the pattern is like this. 1, 2, 3, 4. 1, 2, 3, 4. So in the pattern, the data sheet says that this one is what? 1. This one is what? 2. This one is what? 3. This one is what? 4. This one is what? 5, 6, 7, 8. Once you attach these two together, it will draw this wire to here. 2 will come to where? Here. 3 will come to where? Here. 4 will come to where? Here. 5 will come to where? Here. You understand me now? Even though the arrangement, this is the reason why sometimes we scatter arrangements on schematic if it's when you want your schematic to look what? Neat. And you don't want crossing wire. You can rearrange the what? Pin. You understand me now? So you have a neat what? Schematic diagram. Because if you have too much wire crossing, it will look what? Rough. You understand me now? So, but if you rearrange it on the schematic, on the graphical symbol, make sure you have the right pattern. So by the time you want to do your PCB, it will automatically what? Assign it to the right. So that's it. So are we done with the pattern? Just draw the box, draw the 4 pins, name the pins, give it the right this thing, number. So we assume this side is our what? Primary side, and this side is our what? Secondary side. Then save it. Is it safe? Save it. Is it safe? Have you saved it? If you have saved it, I've deleted my own transformer. I didn't know. If you have saved it, come to pattern. Go to where you go to your component editor. Yes, go to component editor. You will see your transformer here. Come to pattern. Have you got to the pattern? Do you see the step? Assuming this is your transformer. Just assuming. There's no time for it. I just want to quickly use this one as an example. Assuming this is your transformer, right? Have you grouped it?
Yes.
I'm going to group it. Sorry, I didn't know when I deleted that. I light everything there. What? Group it to make it one. Right? So you can move it as one component. Good. I'm sure you've saved your pattern.
Yes.
Let me see my own pattern. How do you what? This is my own pattern. I've saved it already. It has been saved. I have too many tabs open. That's right. This is my own transformer. You have seen it.
Yes.
So come to where? This is your graphical symbol. Come to where? Attach pattern. Once you get to attach pattern, come to where? Pattern. Go to what? User pattern. You can see my own trans. Once you click on trans, now come down here and click on what? Trans. Can you see it? You can see that it automatically connects 1 to what? 1, 2 to what? 2, 3 to what? 3, 4 to what? 4. Let me go back again. Are we here? Are we all here?
Yes.
You've seen this. Have you saved your pattern? Just draw a box and something for us. I've corrected this. I told you what to do, sir. You right click on it, sir. What's your this thing? O diameter. Sir, look at it.
That's 0.0.
Please, have we saved our pattern? Can we go ahead?
Yes.
So come to what? This is my own pattern. So as it is now we can create. Now we can create what? Graphical symbol. We can create pattern and we can attach the what? You are not done attaching the pattern. What was giving you a problem? What's the problem? Maybe where did you save your pattern?
No, I've seen it. I don't want to continue for where it stopped.
Come to this place. Look, this is the graphical symbol.
Yes.
Click on what? Pattern. Once you click on pattern, come to what? User pattern. At this user pattern. Click on user pattern. You will see your own component library, which is what? Anything you use to save it. I use trans for my own. Click on it and come down. So you can see what is showing here. Pin, go to the pad number. 1 to 1, 2 to 2, 3 to 3, 4 to what? 4. Then after that, click on what? OK. Click on OK. So now let us. Is what? I don't know.
The mapping is correct. But then you see, I mean, compared to yours,
That is the name of your pin. Now check the number of your pin. Maybe everything is focused on. Where is it showing up from? Is it on this one or this or your schematic? Is the graphical symbol that is showing you? The numbering of one is scattered. That's why I say you have to make sure the pad number pad 1 to 1, pad 2, see, pad 3, pad 1. There's something wrong with this. Go and check your pad. Then sometimes maybe when you are doing copy and paste, you copy 2 pads of each other. That happens. You won't know that you have 2 pads on you. Which label? So you now put something. This one is not showing the pattern. Okay, perfect. And that's it. The so your pin number, pad numbers are having it. Maybe you have a pin that has the same number or pad that has the same number. Yeah? The number. Yes. Hope you don't have more than 2 pins. Maybe when I just copy and paste. If you have issue with it, delete all the pin number first. Go and delete my pin.
No, it's the pin name.
Eh?
The name, the numbers were correct, but the name was
Okay,
so that's why
The name and the number must be.
yes, now. Let it be the same.
yeah, I think the pin number was correct, so that's why the map correct.
So all what we've been doing so far is just for us to know how you can create your own what? Graphical symbol and pattern. Because you will have this issue due to what? Us getting components locally and you won't be giving the what? Data sheets. But if you know the package name, you can easily what? Get it on the software. Once you just click the what? Package listing on it. So now let's move to what? Schematic design. Let's move to schematic design. Most of the components we'll be using, we are not going to create it. We are not creating it. We are going to pick it from the what? Library. We are going to pick it from the library. on to do what exactly? There's Mac version for it online. So I'm not using it. It's bad. You downloaded it and say it's bad. From this thing's website, the pictures. So the reason why I want us to design a simple circuit, I'm choosing a 5 volt power supply. A 5 volt power supply, it has two different voltage level. A power supply has two different voltage levels. It has the AC part and it has what? The DC part. So by the time you do that, you know the rules when you are designing PCB for what? AC and PCB for what? DC. If I said we should go for a digital circuit first, it should take time. Before we now start going for another what? AC design on PCB. But most times we don't really have AC being designed. Where you can see AC circuits on the PCB is when we are dealing with boards like inverter or switch mode power supply. Assuming we are to take more time, I would have preferred we go for what? Switch mode power supply, but it is more complex. Just go for 3-phase switch mode power mode supply. And we also need to order for the company, but let us just go for what? 5 volt power supply. When you have a 5 volt power supply, the first stage is what? In the 5 volt power supply, you have the source. After the source, you step it down. Step down. After stepping it down, rectification. After rectifying, filter. After filter, regulate, and you have your what? Output. After that regulate, so you can see what? Have another filtering capacitor. Let us just start with the simple one. So the first circuit we are going to have what? The transformer. What type of transformer is this? Step down. Number of turns. Easily identify it. Then, when it comes to rectification, we have two different type of rectifying rectification. We have which one? And what? Bridge. So the first one is how many? Like 1. The second one is what? 2. The third one is what? 4. Who can draw the bridge for me? The graphical symbol. Yes, now you can't be a PC designer if you don't know electronics. Because if someone give you a circuit and he did not arrange the pump, how will you identify it? you agree with him? Look at what he's doing. Do you agree with him? Why?
That is right.
Hmm?
That is right.
That's right. So, like, we talked about semiconductors. When you have diodes, and diodes allow the flow of current in only one direction. And when you have an AC signal, it is always what? Sodium. Alternating from what? 0 to what? 240. Am I right? From 0 to what? 240. So now, at this point, whenever the voltage is what? 240, it goes through here and come here. Am I right? When 240 gets to this point, what will happen? It will only be allowed to pass through here. Why this will what? Block it up. Only 240 will be allowed to pass through here. 0 won't be allowed. But 0 will be what? Allowed to pass through here. So at this place we have what? Negative. So same thing happens at this point. When 240 gets here, 240 will be allowed to what? Go. Allowed to what? Go. Only what? Negative is allowed to what? So that's why we have what? Negative and we have what? Positive. So that's a good one. And after that, you have your what? Filtering what? Capacitor. You have a capacitor here. After having a capacitor here, the next thing is to have a what? Voltage regulator. Voltage regulator. You have your voltage regulator. And from there, you have your what? Another filtering capacitor of like maybe 1 UF. Let's say this one. Let's say 1000 UF. This V in, V what? V out. Let's say which voltage level are we? 78.5. Then we have our what? Output. Output of what?
5 volts.
5 volts. So this is a simple circuit. As it is, it is very simple. Doing the schematic, no problem. But when it comes to the PCB, there's problem. So so now we are moving to what? Schematic. We are moving to what? Schematic. So it's very simple to do this on schematic. I will give you hints on how to get the component of what? On the schematic interface. So you learn the component editor, pattern editor, but now let's go into what? Schematic. And there are some rules too when you are doing schematic. Ground must be facing what? Ground. Voltage should be facing what? Up. Things like that. Even the software will not allow all those. You understand me? It corrects all those things like that. Because we have something we call what? Design rule check. It checks all those things by itself automatically. So now let's go to what? Schematic layout. Schematic layout. So if you come to the software like this, click on it, this will appear. If you launch it, this will appear. So you'll be able to go through what? Component editor, pattern editor. Now we are moving to what? Schematic.
And one good thing about PCB design is when you have a good view. Like me, I don't use laptop at all. I don't use laptop at all. I use 221 inches. 2 inches.
You use what?
221 inches.
Okay.
Not TV.
You two monitors. Okay.
Like this. You will see. So now, let us look at this interface very well. By this side here, you have what? Place component. Place component. So under this place component, we have, if you click on it, we have what? Component means the general component, where you have all component what? Libraries. All component libraries. Here is user component. User components are the components you created by yourself. Like for example, there was a time I was lecturing some people and I did this one. There was a time I did this one. You understand? So, but this one just come to what? Components. If you come to component, you see list of what? Different components. Discrete components, discrete SMD, symbols, EIC, net ports, antennas, batteries, buzzers, capacitors, connector symbols, connector back, everything. After all these lists are just what? General component list. After that, this often have what? Manufacturer component list. All component what? Manufacturer list. So if you pass all these general ones, you start seeing other manufacturer names. Starting from here. You can see these are what? Component manufacturer, Actel, Allegro, Ultra, AMD, Analog Devices, Atmel. So if you buy any component, as long you have the software, you can easily access their what? Schematic, their graphical symbol and their what? And their pattern. Everything is there. Cypress is there, Dallas is there, Diamond is there. So everything is here. Atmel guys. So the first component you have to pick here is what? Your transformer. I didn't say that.
Sorry, sir, I'm lost.
No, just click on this here.
Yes.
This component here.
Okay.
Component, just go to components. This is where you have all components.
I've done that.
So now the first component you are going to pick is what? Transformer.
Okay.
So find where there's transformer here.
Okay. There's no search.
There's search there.
Just type T. Just type T to take you down.
Transformers. Can you see it there? It's lengthy now, but be looking at once you are look at what graphical. Okay, designing transformer in which you can use it for either 140 or 240. So assuming I'm manufacturing transformer now, instead of me to manufacture for people that are using 110 or people that are using 240, no. So those transformers will come with 8 pins. How many pins? 8 pins. Not the one you are buying that you just buy at there. Electronics now. These are most of all the transformer comes. 1, 2, 3, 4. 1, 2, 3, 4. If you are using it in a country whereby it is 110 volts, you will tie this and this together. You will tie this and this together. So you are using what? No, sorry. You will tie this and this together. Now supply with for 240. This one 240. But if you are using it for 110, tie this and this together. Tie this and this together. You understand me now? Tie this will connect them together. So that means using this pin and what? This pin. So these two pins. But you have to make sure they are what? Tied. That's what? 110. You understand? So this one, if they said the transformer is 5 volts, most times it's 12. 12. If they said it's 12 volts, that means depends. They can tell you that this one is what? 12 and this one is what? 12. If you tie this and this together, you get what? 24. But if they tell you that okay, it is 24 volts, 1 amps, 1 watt amps. If they tell you that it's 12 volts, 1 amps, what you'll be getting here is what? 24 volts, 0. What? Do you understand? So, but if you bridge it, if you tie this and this together, you now get what? 12 volts. How many amps? 1 amp. So once you see something like this, you can make use of what? Is that right? This transcription. The what? Okay, it's different. You know, my own is a paid version for and update every time. No, my own is updating every time. Update. I have to update. Maybe you don't have internet. Then you go to no. Just come to help. Yes, now. You see, my own is still. You can see too. It's full. Still August 5 say. So check your own. Check your own version. No, I'm supposed to update it. So. Your own is what? 304. You see? It's higher. It was during their training I downloaded that one for them. Now I told you I don't use this system. I don't use this. So that's it.
It's not the transformer.
Different. I don't use this one. Oh my god.
But what we have here is 147.
We are not in the same category, but
You know, just find a transformer that has 4 pin, whereby the turn 4 pin, sorry, whereby the number of turns at the primary is higher than the what number of turns at the what, and if you can't find it, go and create it. I don't use this one for my business. Don't worry, I'll be doing it. Once I'm done with my own, you do your own. Stop now. Don't go up. Ah, must now be down. Hope you are looking at how I'm doing my own. Ah.
what's your own like this?
I'm picking everything in. It's there now. Capacitor. Capacitors. Thank God our software are different. You find it. Filter. There's filter to deal. Okay. Stop that. This one is too small for you. Okay. after that, another question capacitor. This is now. After that, connector symbols. Are you following up?
You can't put a regulator here.
Look at how I filtered it now.
It's different. I don't see you the way you guitar your.
You do it or you as a component.
I mean, as you have done it before.
What is this?
It's not yet.
See,
The version you are using is higher than ours.
Yes.
It's higher than ours.
Oh.
your own is the highest now.
No, your own is full version. Our own is
That's
freeway.
simple where you can just pick.
I've told you what to do. It's there. Come here. I just place it here. I apply filter. All what you want to find, just 7805. This one. Make sure you put this one to what? All libraries. It's there. I think that software that we downloaded it to train the first set of PCB design and fabrication last year. Ten minutes oh. Yes, I have this. The way I fit tag or what?
Yes. All that.
Let me let you show again. Just come to this place. Filter. Look at filter. Click on filter. Make sure this one is what? Search area should be what? All libraries. Click on what? 7805. If you just have the idea or just Google search like just or the package name.
Okay.
If it's resistor, just write RES to come out. You select. So see now, I just click on apply filter. Start searching for it. See, 7805 is on 20 something percent. I stop it and I click on the one I want. There are many there. Anything that has 7805 in it, you just bring it out. But this is the real one we need. 7805. go round. No, no, not even. This one is just once you know this one, that's it's very friendly.
The source.
Sauce is under listing. Sauce is under symbol. And that's how I have to ask you the same thing for that body. Just start from that.
Past 3. That's 38. That's 38. 2:45 break. That's lunch break. And we resume by 2 then past 3.
Very okay.
So I don't know.
This are this what side? So what's the rev desk for this PS1, power source 1. So what's the value? 240 volts. So you need to fill all those data. Huh? So that's it. This is what? Power source. Then looking at the PCB, like for example, if you are to power this your fan or any device, it has a power cable now. A power cable whereby you have a 30 amps plug, and the 30 amps plug is going to a particular port, connection port on the device. So that means that connection port on the device, it has to be what also soldered on the what board. So for that reason, this one too we should attach a pattern. This is a symbol, but we should attach a pattern to it. So pattern, it should just be a 2-0 connection whereby do you understand what I'm trying to say? For me? Not a switch. You know this 13 amp socket plug, táwọn rechargeable fan máa ń lò yẹn, that most of all this rechargeable fan or lamp normally use. Once you plug it, you have to connect it to your maybe fan or this thing. And the connector, that black connector on it too, is sitting on the PCB. We have different types that can be what? Soldered on PCB. So that means you have to create an O for it. I'm coming. I will show you. Let me just read it out. So now, look at what I'm saying. Please look up. Oh. Look at this connector now. AC power what? Socket. So that means you have something like this on the board. So look at it. Look at the connection points. So that means you need to even what get the data sheet of this what connector, and you create a what a pattern for it, whereby this will be placed on the board and what you solder those what these 3 points to the board. So we have different type, because you don't expect or this type. You understand? Our connector, this connector will be on the board. So the type of connector you are using is what will determine what the pattern. So if I'm using this connector now, I'll go to the manufacturer. I will check the what the data sheet, and they will tell you the distance between the 2 pins. If it's 3 pins, you get the dimension, you get the diameter, Uh-huh. So when you create that pattern, you now attach it to what? Source. You attach it to what? Source. So let me just find a random connector for this one. So I can come here now. Connector. So I'm using this. I'm using what? This. So this 2O is representing where it is going to be what? So that. Okay. Some pins of this one. Let me see. Cancel. I won't stress myself. Let's go for this. So this one we selected now is just to what? Represent connector. It's just to represent connector.
What would I use to search connector? 64456.
And you can use this one. You can use it in press HDR2, something like that. Press HDR dash 1 times 2, just leave at it. Put it like that. So that's it. Then our voltage too, at the source. This is the output voltage here. This is the filtration capacitor. We should have another what? Connector too at that point for us to get our what? 5 volts for the output. Another connector to here. So now After placing all our components, now the next thing for us to do is to what? Connecting them together. Yes?
Please, when I was selecting the pattern, it's telling me some things of the ES1 don't have corresponding pattern part.
Just
They will
ignore
be
it. Go and
connected.
select. Go and select another new one.
Okay,
Go and
so
select.
add the
Go and
power
select a
again.
component.
Okay,
Select a component here. That's why when it's giving me that
okay,
this thing, I will still change everything.
alright.
So we have. So let's. To me, normally what I do here is what pin name. They call it AC2 here, abi? Just put what live. I'll do it. Can change it. Live and what? Neutral. So selector. So if you want to do the wire connection, this is it here. You see? Place wire. Can you see? Place wire. So once you click on it, so bring this icon. Make sure they're straight. Good. So can you see it now? So this entire uh, net, we call it what? Net. One thing about all this terminology used in all these class software, they are the same for all PCB design software schematic. So we call them what? Nets. So the first net is called what? Net 0. The second net is called what? Net 1. But what's the name of this net? It is what? Live. So if you click on it, live. What's the name of this? What's the name of this net? Neutral. So once you click on this, live, you know where it starts from and you know where it branches. Live, this one is what? Neutral. So now the next one is what? What's the name of this? What? AC what? Connector. AC AC connector. So that's it. Then what's the details for this transformer? What's the value? 12 volts. 12 volt transformer. No, 12 VAC. You understand? Because the voltage coming at this end is still what? Alternating voltage. So you have to be precise. 12 what? VAC. So now this AC1, this what? AC2. Connected like that. So you should call this one what? What should be the name of this net? 12 volts. Okay, 12 volts. 12 volt AC1. Abi? Then how about this one? So that's it. Then now we have our what? This is our rectifier. The function of this bridge is to what? Rectify the what? 12 VAC to what? 12 what? DC. So at this point, we are going to have what? Our 12 volts here. You can see? Are we getting it? Are we on the same page? Eh? So what's this? This one will be what? 12 what? VDC. Next name 12 VDC. Why this one is what? Ground. This is ground. This is ground. So it comes here. We now call it what? GND. GND. Okay. So now we move to what? Next component. Let's drag this up like this. So now 12, this thing is going where? Into the input. Am I right? Then this capacitor, what's the value? 1000 UF. Most times we use 1000 UF 25 volts. 1000. There's a formula to calculate this capacitor. Yes, there's a formula to calculate it. Most times, the formula to get the value of this capacitor is in the data sheet of this voltage regulator. Value you are going to use. And the formula itself is we request for the what? Current and the what? Input voltage. You know, the capacitor is just working like it's smoothing the ripple. Because if you use an oscilloscope to really check it, for bridge, it's just little ripple. For bridge rectifier, just little ripple, unlike others. So 1000 you have 25 volts. UF. Now put slash what? 25 volts. That's the value. This is ground. It's connected to ground. It's still continuous. Then this is another was fusion capacitor. This is our output voltage. What's the pattern for this one? 7805. Value to is still what? 5 volts. Let's say 5 volt 1 amps. This is very small filtering capacitor.
What is that capacitor?
Huh? It will work, but it's better is there. Sometimes. Then this, should we add this thing to it? Indicator. LED indicator. Let's add an LED indicator to it. We just need two components, resistor and what? And LED. So I can easily find resistor here.
Sir, can we add Zener diode?
Zener diode for what purpose?
It's also a voltage regulator as well.
No. It is not the best design for now as it is now. It is what we can use here is voltage regulator. The reason why they make use of Zener diode sometimes is for complicated power supply.
They won't use it for reference voltage.
Zener diode is something I've practicalized before, whereby you see that okay, this voltage regulator may not perform what you want. That's when you make use of what Zener diode. I remember there was a project I did then whereby I had no option than to make use of what Zener diode. That's been long. That's like maybe 8 years ago. So let's add. Let's find the resistor here. There should be a resistor here. There's a small resistor. You can see that it's giving the ref des automatically by itself R1, U1, J2. Then let's find an LED. Is an LED. So yes, it's a polarized component. Resistor now is not a polarized component, but this is a polarized component. If you put your this thing, you see it. You write yeah, you see cathode, anode. Can you see it there? A, you see this is D2 abi. Look at it. A means anode. A means anode. K represents what? Cathode. So this is the cathode side, which is the negative side of the diode, and the anode side is the what? Positive side of the what? Diode. LED, light emitting diode. This goes to what? Ground. We are still on ground. Then this is our what? Final what? Output. So as it is, if you have this component and you arrange it like this, you are going to get a 5 volt what? 5 volt voltage. So as it is now, what is the name of this net? Five. Five. And still ground. So that's all. So use a complete circuit for what? For 5 volt what? Power supply. 5 volt what? Power supply. So that's capacitor. Use resistor. You can just use 1K resistor. 1K is okay for 5 volts. Value should be what? 1K ohms. Okay. So as it is now, we have a complete what? A complete what? Schematic of what? 5 volt what? Power supply. I think it's very easy, Abi. What about your own man? Are you not doing it on your system? Ah. By bí mo ṣe ń ṣe náà ló yẹ kẹ́ ṣe máa ṣe. Okay, let me give you time to work on it now.
You rename the American capital.
I did not rename it. It's a default. Uh, I explained to you now. You are soldering the connector at that point. This is representing a what? A connector. That's why I showed you this connector. It's representing this. We are just using it to represent what? This. Normally, if you are using this, you get the data sheet of this. You get the what? The pin diameter and the distance between the what? The pin. And you also get the area at which it will be covering on the board. You create the pattern, attach it to that what? Connector. This so that the pattern will appear on PCB. This is just a source indicating that AC yes, that AC the connect that this is just a symbol without pattern. It's just a symbol. There are some symbols that have no pattern. If you come to this place, let me show you some symbols that have no pattern. It's just like you saying jumper. Test point has pattern. Sometimes you have to put it. Grant has no pattern. It has no pattern. All this VDD. It has no pattern. All this one. Even normally safe. We can use this as ground. As what? Ground. Let me show you something. If I'm having this one as ground, at this point like this, I can just hide wire. Like I hide the wire. So if I click on here, you see all other parts that are ground are what? Being highlighted. Am I catching being So let me still do it like this. Should I start all over again?
But this software doesn't have a simulation, right?
No. Doesn't simulate. And Pro Tools demand simulate at Optium. Pro Tools and Optium, and when man simulate. Optium. Optium is number 1 in the world. Number 1. Àwọn máa ń lò but I don't. Live wire. Students. Yes, sir.
If you are using Pro Tools for the design and you get the Java file, it's the same Java file that you fabricate.
Yes, but Pro Tools there are some limitations. It doesn't have all this design check. Like you understand me? All these ones are for you
so
to.
This auto routing is not too.
All these ones that they have design recheck. You can easily trace any faults on board. So many features on it.
Compared to Optium.
So this one now you can come here.
Engineer,
yes, sir.
Compared to Optium.
No, Optium is number 1, sir, in the world. Optium that has full license. License software is more than 1 million. Crack version that feature. So you can see when you check it, say no what verification, no error found. So you can see all this thing here.
The red now.
No error found. No error found. Most times in schematic you won't really get error. It is when you want to do PCB. Schematic you don't really have errors. It is on PCB design. That's when you start getting errors. So are we clear with this or should we repeat? Because the next thing I'm going to do now is to convert this one to PCB. Convert to what? That's all. Okay, it's long. I think I've attached it. I was just my young man. I attached the pattern. But leave it, I ignore it. So now this is what?
Layout. That's a transformer.
This is the transformer. This is the what? Bridge rectifier. This is the what?
Capacitor.
Capacitor. This is the what? Voltage regulator. Come here, file. Convert to PCB. No, not here. On schematic, where's the schematic? On schematic, this page is for schematic. You can see schematics. File. Convert to, it will open it by itself. You can just, no, you don't need to group. You just press and Control B to group. That's all. Don't go. So this is the PCB. Convert to what? PCB. Then after that, you do your component arrangement. You do your board outline. Just now, I just saw a mistake. Because I made a mistake. On the circuit design, I was expecting something to be connected. Look at this. This one is wrong. It's wrong now. Delete. It's wrong. This 5-ohm connector now. It should come before this resistor. You be the 5 volt one now. Uh-huh. Do you understand? This is an indicator here. My indicator.
Okay, just an indicator.
Uh-huh. So if I want to let my schematic to be neat, this is what I will just do. I will leave this like this. Sorry. I will leave this like this. I won't use anything. I will just say add to what? Net. What's the net? 5 volts. Okay. My height wire gone. Height wire. What 5 volts be already for me. This one to add to what? Ground. Ground. Okay. I can hide the wire. If I click on this, you see it's telling me that this one is connected to what? To that point. If I click on this, it's telling me that this one is connected to what? To the ground.
Sorry, engineer.
Sir?
Please, when we were renaming the net for that transformer,
Yes, sir.
the other side of the transformer is going to be what?
It depends on in Kotoba when you understand none. So
The 7, LCAC2.
Just call it black, 12 VAC2.
Okay.
Because this one what? 12 VAC1. So that's it. No, now so you see I did the correction there, right?
Yes.
But I can't say for sure,
Power supply.
5 volts USC. Save Abi.
Yes.
So this is the what? Any correction you do on schematic, you can't correct it here. The only way you can correct it is to update. You come here and you said that what? Renew layout from what? Schematic. So come here by component, then you find the what? 5-way power supply. Then you open. You've done this one. So to correct everywhere. That's correct. The what? I'm gonna repeat that roller again.
But the labeling, if after finishing the entire circuit diagram, then now start labeling
Labeling what?
all the parts, just like the knife, the neutral,
The nets.
yes. After you have completed this, you know the one we did, as we are doing it, we are labeling.
Yes.
When you now want to attach it to the PCB,
just update.
because my own is complaining.
That what?
I didn't completed the labeling, and I want to.
You can move now. But any changes you are doing on schematic, you have to what? Renew it on your PCB here. We'll repeat it tomorrow morning. So you go file, renew layout from what? Schema by component, and you go to the file and you select it. So now this one is not yet completed. You are still going to
Sorry, sir, if you make changes, how do you go back to update? How do you update it to take effect?
file,
Okay.
renew layout from schematic
Okay.
by components.
Okay.
Then you select.
You must have saved the schematic.
Then any changes you do here, you have to save so that it will reflect. You save so that it will what? Reflect. So schematic. Then I'm still going to remove this one.
Maybe when I stepped out, did you simulate before?
No, we just simulate.
Do we not have to before we go to the PCB aspect of the work?
No, this software does not simulate.
Oh, it does not simulate.
Yes.
Because you made mention earlier that it's quite possible to get this schematic, right?
Yes.
But when you get to the PCB layouts, you will be having issues.
The issues are maybe component placements and routing. So the issue of simulation missing is not critical because usually when you have your schematics, you are supposed to simulate before you even go to the board. If you those are student projects. Student project. Yes. Okay, when the schematic they are bringing to you at this stage, they are already working session. You don't have to work. No, you don't. Your own problem is not no, because again, how do you certify that the circuit is working before you get to the PCB? Before I get to the PCB. I don't think I like that aspect being skipped because usually one should be able to simulate. Simulate. Those are student projects. Which serious circuit? Complicated. Can the schematic can it be complicated than this type of project? Where I use 144 pins. It depends. This is complicated. This is complicated, of course, on its own. But it's okay. I understand. Use protein for the simulation. But you understand. I understand, sir. Let me let me explain to you. Let me explain to you. There are design rule checks that will do all those things. When you are doing a particular huge project, you make use of MCUs. You make use of MCU, IC. So, for example, now the chip that was used here was Teridian. Teridian. This is an SoC, system on chip. Before you do this, because the production of this, then you did 40,000 of this. So before you even embark in project like this, you will have gotten something we call a demo board. You get me? On that demo board, you have everything this SoC can do, and you have the complete schematic in the data sheet. I am sure that everything is okay. It is from the manufacturer. You understand, sir? It is what? From the manufacturer. Just make sure your schematic comes. So in that demo board, all the function this chip can perform, it is there. The full schematic, it is there. Just okay, this is the circuit I want. This is what I want it to do for me. Then you can order. You can ignore other peripherals that you don't want to use. Then if you are good in electronics, you will see some circuits yourself. You know that what's this? You will see it. You will see it right from electronics. If you see a wrong design, while you are doing the route, you just be like this. Okay, do you know how this works? You are looking at it like this. Is a combination of small different circuits, and the connection between one circuit and the other circuit will just be dual communication. Receive and transmit between this and this. So as it is here now, this is the main chip. This is an SoC. This is an LCD. An LCD is up to the device. You know that okay, you have to assign GPIOs to what? LCD. That's all. This one here is an optical device. It's a small circuit on its own. Interface it with the UART. This one now is the keypad. Interface it. So all those things are just. If I open the schematic for you for this one, let me open the schematic so you understand better. And actually, where are you? Okay, maybe later. Maybe after 2 or 3 days. No. Actually, there's a question that I cannot ask now because let me wait first and see. We are not here for electronics. We are not here for electronics. Not electronic class. As a matter of fact, I'm actually even more interested in. Okay, this is a schematic, diagram. This is how we do the PCB. Then we go to the printing. In fact, that's what the help. I know. So I was just thinking that maybe that simulation aspect is part of it. I understand that in a serious project, it's not required. No, before you do, you have to prototype. Iteration. Prototype now. No, no. No, sorry. Okay. For example, look at this is a schematic of a small device. You can see the schematic of this alone stand alone. Key part stands alone. This stands alone. It's just combination of small circuits connected together. Most times, what connects those component and another component together is just UART, which could be SPI, could be I2C, or SPI. So that's it. Okay. Okay. Again? Okay. This is the connector, right? These two connectors, as one of it is supposed to connect to 5 volts. This is 5 volts. What's the name of the net? 5 volts. You can see it's showing 5 volts. The second net is what? Ground. Just come here. You can choose anyone. There's no polarity for that. First connector, add to net. Which net? Maybe ground. Okay. Then this one too. Add to net. Which one? 5 volts. Then you can say connect to that wire or connect with wire. So just press OK. That's it. Then you can hide it. What's the question, sir? And when you get to this stage, the next thing for you is to do what? Component what? Arrangement. Component arrangement. This one is not okay like this. I need to turn it around. Which one will be better? Okay. I think I prefer it like this. Prefer like this. Let this one come here. Okay. Let this come here. Let this come here. So when you are doing things like this, you have to manage what? Space. So I know you. Maybe I'm too fast. Not that I'm too fast. I understand. But you get there. Look at how I arrange it now. Arrange everything. I would prefer this to be here. Component arrangement is one of the major issues in PCB design. Yes, and avoid tracks crossing each other. It is one of the major issues. You can spend, if I'm to train you on component arrangement, you spend 1 week. You spend 1 week. You spend 1 week on component arrangement. The first set of people is thought they were. So you spend 1 week. Because look at this now. I have to consider it's a small circuit. So look at this one. It's better like this. Do you understand? Let me show you something.
Is there any rules, maybe some guiding rules in this layout?
We are going to get it. Component arrangement, we are going to get it. So that's it. Look at this now. Before it was like this. You can see if I'm going to route this, I'll route this like this. But this will affect. Let us start with small routing first. That's where we are. That's it. So, enter. Let me just delete this. See, if I'm routing this now, it's coming like this. What about this? So then you have to make sure you have the shortest track as possible. What? The shortest as possible. So that means now what I need to do is what? Rotate this guy. So look at it now. So this can what? Easily dot out like this. Then come like this. Look at this too. I've calculated this. AC, DC. I separated them. This must not, AC side must not interfere with DC side. And I need to manage space. That is why I look at it. Okay, the best way for this thing to be is like this. That means AC circuit will start all from this side down to this side, then half of this part. You understand what I'm trying to say? So my DC side will be from here down to all these parts.
No cross lines, no.
Yes, now AC and DC. Look at this place now. Look at this circuit. This part where you see that there is no green stuff there is AC. You can see what's here. N. What's here? L. This is a transformer. You can see. These are the pin for the transformer. These are the pin. You still have AC here. But after this bridge rectifier, because this rectifier used here is a what? SMD. Surface. You can say at that point that's where the what? AC stops. There's nothing like copper pole for AC. You run the trace alone without what? Any copper pole. And you avoid any DC component around it. So this arrangement, let me just finish it up so you see what I mean. You see? Skip. Then when you get to where you have ground, you don't need to route ground. You don't route ground.
You just leave it.
You leave it.
How do you connect them?
Copper pole. The entire copper pole, you get it.
Oh, okay.
For example, now.
Oh, P-O-U-R.
Yes. Use copper pole for ground. This entire green you are seeing are ground. Look at it now. Look at everything that are what? Red are what? Ground. They are all ground. So if I click on this place, you see. So the entire copper pole is used for the what? Ground. And why do we have ground? Ground, it helps to absorb any interference generated by other what? Traces. yes, from any other traces. It absorb them. You understand now? It what? Absorb them. There are some rules, just like receive and transmit track too. It's either you shield them with copper core or you double the space between them times 2 their width. The width of the trace times 2 will be the spacing between those two tracks, or you shield them with what? Copper core, with ground copper core. Still get there. So now, for me, what I do is I will just hide the net. Hide the net. For that. Hide net.
For the ground.
Yes. No, no, I don't want to like this. Sun is even disturbing me. So when you have something like this, let me just put this one here like this. I will take it off later. So tomorrow we are going to repeat this section tomorrow. And there's something we call board outline. Board outline. Why is it here? It should be around. Okay, this is here. Or this is here. So this is here. Whenever you're routing and you're seeing that red sign, it means error. So this is the size of the board. You can limit it. That's the board outline. Then for this type of design routing, you can't make use of two-side routing, just one side. Because you don't have, when you have less than 20 components, I don't expect you to use double-sided. But above 20, but if you have any component below 20, you should be able to arrange the component in such a way that you are going to route it in just what? One side.
Another question, sir. Do you habitually decide the size of the board, or are there standard sizes available in the market that you have to trim your work to?
No. It depends on your listing, your enclosure or your case. The casing. Yes.
That means not the board.
Yes.
So you mean the
Enclosure.
you mean before the printing?
My name is from Mobile School. So we are privileged to be here to come and explain or put you through some basis of electronics design using some application and how to fabricate PCB. And I want to understand maybe the majority of the people here are electronics people. Am I right? So that sometimes terminologies being used will not be strange. The only thing that maybe will be different is maybe the application that maybe we'll be using to guide you through the design process. design process. We'll be training you on how to fabricate a PCB. So, once again, my name is Melo Bashir. I'm here with my colleague, Engineer Gideon Ojo, who will be the one that will be taking you through the design